Here's how to enter a confidence interval for a proportion, a percentage, a portion, however specifically you've seen it worded. This problem is off my video 7.3 part 2 at timestamp 3 minutes and 45 seconds. Since the proportion confidence interval needs to have a lower and an upper bound problem, we solve the problem once with a minus and once with a plus. So to do it first with the minus, we go ahead and start off with just 0.4. You don't need to type in the lead 0. Then we're going to subtract. Now we're going to kind of keep working from left to right to subtract the 2.33. We're multiplying with the square root, so I like to hit times. You might not need that times. But what happens is the way we do a square root, remember, is we have to have the value we're taking a square root of first for this calculator. So what we need to do is a parenthesis above the 8, shown in the top corner of the display, to start the interior portion of the square root. I have parentheses for clarity, especially with the decimals, but we don't need those in our keystrokes. We can just type in 0.4 times 0.6 to get the numerator, divided by 200 to get the denominator. But now I need to close off this quantity to indicate what's inside the square root and physically take the square root, not the answer, because all I have found so far is the square root. I need to finally hit the equal sign to get the lower bound of my proportion confidence interval. Unfortunately, with this calculator, there's no way to type everything in and without having to do it again, to get the plus. So you don't need to hit clear, but I like to. 0.4 plus 2.33 times parenthesis to start my square root, 0.4 times 0.6 divided by 200 end parenthesis. Take the square root of that parenthetical value and now equal the whole equation to match the value in the video. I sometimes found my students actually like to solve this problem better going backwards. I don't have this written down, but basically they'll start with inside the square root. 0.4 times 0.6 divided by 200. Take the square root of that value and multiply with 2.33. Then you might want to write this value down, or you could then say, plus 0.4 to get the upper bound. The problem is if you want to do this method with the lower bound, what ends up happening is if you don't write down the value, what am I doing? Times 2.33. If I don't write this down and do 0.4 minus it, but if I do minus 0.4, I get the correct numeric value, but the incorrect sign. So it's another way of thinking about it.